Now, can you see it in the presentation mode?
Yes, we can.
Okay. Hello, everyone. Welcome and thank you for joining us for today. Zaid Malik, and together today with Mohammed Al Fateh, we will represent for you about what we call plotting the path of machine learning project. And I will start by introducing myself. I'm Zainab Malik. I'm from Sudan. I did my bachelor in electronics engineering. Then I moved to computer engineering in my master's and PhD. And generally, I'm interested in applied machine learning, which means all different application of machine learning in our real life. And today we will learn more about how to go into machine learning, how it starts, how it's end. And I know actually most of you, they may think that machine learning can sound a little bit scary at first with the algorithm and data and all this stuff. But actually today we try to make it basic or simple as most to make you understand more. So we are not going deep into coding or algorithm. We will just want to focus into the big picture and like what does machine learning project really look from the idea until the decision. So here is our content we are going through it today. So we will go from the beginning, defining how to define the problem, and then how to collect our data, how to prepare the data for machine learning, how to select the model, how to train the model, and then after that, how to make the evaluation and the deployment step also. So you may ask for the beginning, like why understanding the machine learning process matter? Actually, like now you can think if someone give you a ticket and they say for you, okay, you are flying tomorrow without any details. What will you feel? You will feel confident or no? You will say, no, it's spam or something like this. So machine learning is the same. If you want to start, you need to know all the steps to help you to figure how it will go. Because when we have a clear process, we will have less risk and better result as well. And also knowing the process of machine learning project, it will help you to figure where is the error. I mean, if you have, after modeling and after that training the model, if you have some problem in the model, in the accuracy or something like this, you may figure immediately, if you know the process of machine learning project, you may figure immediately that the problem in the data or the problem in the scaling or the problem in selecting the model. So already we have problem in machine learning called overfitting. So mainly or basically it is when the accuracy is very good, but when you apply different data, the accuracy goes low. So when you have this problem, you will have it all if you try a machine learning model. You will know exactly that you will go back to data to check the balancing of the classes. So this is one of the importance of knowing the process, that if you get an error, you will just get back to the process or to the step that you know, and you will figure what's the problem. So now we going to our first step, which is defining the problem. So here in defining a problem, actually every machine learning project should begin with like powerful question. So now here, let's take example of healthcare problem. So we have, we want to detect if the person have diabetes or not. So first, we create our question that can we detect early sign of diabetes in this person or not? What's the second thing that we want to have here is data. So our data should be the medical record of the patient, maybe blood sugar level in previous year, BMI ratio, age, family history, if there is someone have diabetes there or not. We need to know all of this to give this information to machine learning and to train the model about it, to give us a decision that if this person have a diabetes or not. If they have and we detected in early stages, that means the doctor can act very fast and we can save life, as we may say. So this is basically what I mean by defining the problem. After that, so yes, here is just example from real life question. So in customer and business intelligence, we have question like, we can put question like, which user are likely to stop using our application in the next 3 days? So we will check the activity of all our customers, and we will see how many times they enter the application, how many times they how many times they stay in the application, and then after that we will decide like, okay, there is some of the customers didn't enter this application for 2 weeks. That means they are probably uninstall the application, or they will not work with it, or they have feedback on it or something like this. Also, the second example is what kind of product will this customer buy next. So this also will help the market owner to just predict that next month maybe there is festival or something, and most of the people they came to bring a specific something. That's why it's better to offer it in our market. Also, here is an example of question like of the problem. Can we segment customer based on purchase behavior? So if we have many customers and they buy from online shopping application, we can figure that the people from this age to this age are active in buying a specific something, and people from this age to this age are just buying one in a month or something like this. And then after that, you can make your business plan according to that. Also, here is example of healthcare. So also we can. This is an example of diabetes already I mentioned. So we will check if from the history of the patient and all of that, we will check if they are having diabetes or not, or are they more in to have diabetes next year or not. And also here, if we can detect X-ray images to know if this person have a problem or not. And also we can detect if the person have malaria or not. So this is example from healthcare. Also, this is example from social media and text. We can also like make a classification for text if it is for the comment. I mean, if it is positive or negative or neutral, and also this something is used for hotels review and also airlines review to check how customers are satisfied from that. So here, as you can see, there is 3 tweets, and here the classification of it, if it is positive or negative or neutral. So yeah, so the most important part of machine learning is data, actually, as you may guess. So what do we look for in our data? Whenever we have data, we should ensure that it is good quality. That means from where we collected, who collected, how we collected, when and where we collected, and also why we collected. This why we collected related immediately with a question or defining the problem. Who collected? Because we need to trust that our data is collected from some area or some company that are trusted. And how it's collected is also important because there's many standards that the data should be like this. All information should collect it from all the person should be the same and all of that. The second thing also, we should care about the quality, the quantity of the data. I mean, if we're collecting data for malaria to determine if people have malaria or not, we should have samples from people who have malaria and people who don't have malaria also. So quantity also is important, and balancing the data also is important. The third something is relevance. So if also we collect data, for example, to detect the face of the people, so at least we will ensure that all the images we have, it have clear image about the face of the person, and it appear clearly so that it is relevant to what we want to work on it. And also we should care about the representation of our data. If it is images, if it is numbers, if it is video, if it is text, because for every type of this, we need to pre-process the data in a different way to make it ready for machine learning. Also, as I said, in the quantity, we need to balance the data. So to ensure that there is no bias or low bias actually. So we need to balance the data. If we want to detect malaria, we should have no malaria people and malaria people. If we want to detect dogs or cat, we ensure that the images of cat are as much as the images of dogs we have. So this is the foundation of the data, or the feature that should be in the data. And as we say, as data scientists, so that garbage in, garbage out. So if you give bad data, you will have for sure not good result in the machine learning step. So now we may check the types of data. There is many types of data. There is structured data, unstructured data, and semi-structured data. For structured data, the data that have table or spreadsheets or SQL database. So you can see it in Excel sheet, and every data that in a table format. That data we can say for it, it's a structured data. We have also unstructured data, which is images, video, text, or audio. So here, as you can see, we have X-ray images as example of images data. We have videos also. Here is action recognition project. So you will the machine learning check the video and then check what the movement here or action here. And then after that, the text data, as we mentioned before, it's used mainly for text classification or sentiment analysis. And also we have audio recognition data, which is from the voice, whatever the voice, but here is voice of human, and then it changed from analog to digital. And then after that, we try to pattern recognition and then voice recognition or whatever the application we want to use. So this is about the data types. We have, as I said, structured, unstructured, and the third one is semi-structured. For semi-structured, there is a data type with JSON and also API logs. So the format of it will be like this. So it will not be as a table, but it will be in format like this. So we have a name, age, address, and tags. So also in API logs, it have many information. So before we give it to machine learning, we need also to ensure that our data is ready or prepared, or we choose the right feature for machine learning. I will talk about this a little. So yeah. Also here, collecting the data have two main branches. The first one, use open data sources. There is Kaggle, UCI, and also Google dataset. And there is many actually open resources data for a different type of data. Either it is images, voices, text, or tables. There is many open sources website. The second one is to collect your own data. So you will determine your problem. Then after that, you will go immediately into surveys or interview. You will check patient history from hospitals. You may take school data also. You may take images or videos for a specific problem. You may take the data from sensors, and then after that, like extract the data or make feature engineering on it to work with it. So this is all about collecting the data, either from open source or you can create your own data. So the main thing that we should care about it also after our data, that the pre-processing of the data. And actually, not all the raw data we collected, it's clean. Like most of the time, it's messy and there is maybe missing data. You can find information about someone. For the someone else, maybe it's missed or it is not recorded. Maybe data for Mariam collected 2 times, so there is duplicate data also. Maybe there is wrong format, like especially in date of birth. Some people write it this way, some people write it in this way. So you may get different format in your data, so you need to make it all, to standardize all of it. Also, you may find a strange pattern or something like this. So raw data, not every time it's clean, it's messy. We need to clean it to prepare it to model. So the first step after that is cleaning our data. So if we have duplicates, we remove it. If there is missing data, there is many ways to handle missing data. And also we need to standardize the format and make all the data in the same format. And this leads us actually to feature engineering. For feature engineering, it helps us to extract and select the suitable feature that will affect immediately to the model accuracy. So let's just check it here. So maybe we have many data collected from people that we say diabetes. We want to check if this person have diabetes or not. So we have this data and we have these columns. We have height column and weight column. So if we merge these 2 columns, we may get body mass index. So you will check your data first and see if there is columns that not important. Like sometimes the ID of the customer ID or patient ID, it is not important and already it is different from person to person. So you can just leave it or delete that column because it will not affect in the model. And then after that, you will check that height and weight. If there is some features, there is a relation between them, you can make new column or new feature from them. Also, there is some information like date of last checkup. You can make it as days since last checkup, because if you give the date, it might not that much reasonable, but if you give that this person 15 days since his last checkup or 5 days since his last checkup, so you will know if this person is going to check up every time or they miss it or they do it from long time to long time or what happened exactly. Yes, so as you can see here, also medication start date and end date, you can make a new feature called treatment duration. So you can figure if this person have this sickness, it can take this treatment duration, 2 weeks or 1 week or whatever. So this is what we mean. We need to change our raw data to smart features, or we need to look about it as this. So this is mainly the idea also of feature extraction. And then after that, there is feature selection. So for feature selection, it's like we check all our feature and we say, okay, for medication list, maybe it is not important, it will not affect in the model, so we can delete it. So there is many also algorithm for feature selection, and we may explain it later in detail. Also, there is something called feature scaling. Feature scaling in general, it is like the data may be different between people, person to person. So, and there is maybe many range of the values. So if we take if we take about age, there are many people register in a specific form, and then we collect that data, and ages between 2 years until 90 years. So there is too much range. The idea that by scaling we can make range between 0 and 1, or make it a little bit less, and that will help us to save computation time with machine learning also. So for scaling or standardization, there is 3 types: standard scalar, min max scalar, and mean normalization. For the first one, if you have basic idea of math, you will figure that this is the mean, and this is standard deviation, and this is our value. So our new value will be our previous value, the age of the person, and then after that, minus the mean over the standard deviation. Also for min max, we will take our previous value minus the minimum, and then maximum minus minimum. And for mean normalization is this. So I will give just a small example to understand the idea. So we have age sample of 60. We need to make it between 0 and 1. So we will apply on it the feature scaling. Our maximum age is 80 and our minimum age is 18. And we calculate the mean of all the ages in the form or in our data, and we find it 35, and our standard deviation is 28. So if we want to calculate the standard scalar, it will be like this. So as you can see, the answer is also between 0 and 1. And here also, when we make it with mean max scalar, it gives us like this. And when we make it with mean normalization, it gives us also like the age sample 60, it just became 0.4. So this is just a basic idea about scaling and how the types of it. I think my part is finished here. So if you have question, you can ask. Then we can move to the second part of machine learning model with Fateh.
Thank you, Zainab. Thank you for.
You can write in the chat also.
Thank you for the explanation, Zainab. It was really great how to build a machine learning model from scratch, of course. Do you have any question? If you have any question, please, you can open your mic or write in the chat. But I highly recommend you to open your mic and ask question. Don't be afraid. We are here all to learn. So please, if you have any question, let us know. Yeah, please, Mustafa.
Hello everyone, thank you for the opportunity. Thank you, Ms. Zainab. And I'm asking about the normalization or scaling features. So when we kind of normalize the values, do their values like still with the same effect on the model? Like so we, for example, as you mentioned, we normalize a big number to be small or to be kind of scalable. So does that affect the model, like the accuracy, for example?
If you use different type of scalar or scaling, it will differ in the model. That's why you should try different method to check which is better with this model. And if you mean that like changing the values with a value only between 0 and 1 will affect or not, it will not affect. Why? Because you have like imagine that you have 1,000 records of different people. So all these people, the age of them, you scale it. So it will have the same effect as if you just leave it same as it is. But the idea that in the computation time, like if it is large number, not age, like imagine it is money in account in the bank. So it can be too much money, millions or billions. And then after that, you have to calculate all of that. So if you make all this number or all this between 0 and 1, it will ease and make the computation fast. So it's all about this.
Okay, what I understand, it's the type of scalability it makes different, right?
It makes different because it's different method.
Okay, thank you so much.
You're welcome. Any other question? Okay. Maybe Fateh, you can continue.
Thank you, Zainab, and welcome, Mr. Al-Fatih.
Hello,
Floor